Previously, we have solved the total response yn based on this equation yn equal to homogeneous solution plus particular solution. We also use the value of xn and also initial conditions given in the question. The next one, we will try to solve the difference equation using zero input response. The zero input response is equal to homogeneous solution, where the input is equal to 0 and also depends on initial condition y minus 1 and y minus 2. The next one is we try to solve the difference equation using zero state response. In this case, the zero state response is equal to homogeneous solution plus particular solution, where we depends on the input signal and zero initial condition. In this case, y minus 1 is equal to 0, y minus 2 is equal to 0. Besides, we solve the total response using this equation, homogeneous solution plus particular solution. We also can solve the total response yn using this equation yzi plus yzs. Zero input response plus zero state response produce the total response yn. For example, we are using the same example as discussed previously for difference equation with the same given input signal and also same initial condition, but this time we need to determine zero input response using classical method. So from the previous examples, we have homogeneous solution equation as this one. After we determine the real different roots, which we have 1 over 2 and 1 over 3, the different roots from this equation. For zero input response, we need to assume that the input is 0. Therefore, the system cannot generate auxiliary conditions y0 and y1. But the given initial conditions in the question, y minus 1 which is equal to 1 and y minus 2 which is equal to 1, we can use to solve for unknown a and b in zero input solution. So in this case, we solve a and b using initial condition n minus 1 and n minus 2. So for n minus 1, okay, we used the homogeneous solution previously. So for n minus 1, we plug in n minus 1 in this equation and we use the initial condition y minus 1 equal to 1. So we have the first equation. So based on this n minus 2, so we plug in into the equation, so n minus 2. So we use the initial condition of y minus 2 which is equal to 1, so we have this second equation. So using these two equations, we can solve through simultaneous equation to determine a equal to 1 and b equal to minus 1 over 3. So using these two determined values of a and b, we can construct back the solution for zero input response, which is equal to 1 over 2 with the power of n. This is actually a equal to 1 minus b, okay, 1 minus 1 over 3, multiply with 1 over 3 with the power of n, multiply with un. Un is the unit step response.